This is Mr. Anderson for Math 121. We're looking at Section 6 of Chapter 6. We're looking at long division of polynomials. Now, what we're really trying to see is, does this binomial go into the polynomial evenly, thus proving, hey, look, it's a factor of the polynomial. So, how many times does my 2x go into 6x cubed? We're going to need to start right there because this is a binomial and that's a binomial. So we will multiply my 2x by 3x squared to give me 6x cubed. We want that perfect match for the first one, so it simplifies when we subtract. 3 times negative 3 is negative 9x squared. Draw a line there. So these simplify if I subtract them. And if I subtract, I have to flip these to the opposite symbol. Negative 11 plus 9 is negative 2x squared. It's important to note when you get to this step, you subtract, so everything changes symbols, and then you'll get the first two to simplify. Bring this down, 11x. Now we ask ourselves, what do I have to multiply my 2x by to make it look like a negative 2x squared? And negative x is the answer. Negative x times that is negative 2x squared. Negative x times this is positive 3x. Now, just to highlight the step one more time, I'm going to show you that if you subtract, what this does is this makes this positive and this makes this negative. So when you subtract at this step, you're going to have some simplification like we did right there. That always should simplify. But what that also means is that you're going to probably have something left over here. So let's go with 11x minus 3 is going to be 8x minus 2. So what do I have to multiply my 2x to make 8? Well, it looks like I'm going to have to multiply by 4 in this case to make that perfect match of 8x. 4 times negative 3 is negative 12. And again, I'm going to highlight this with a different color since I didn't do that the first time. If I subtract this line, this becomes negative, this becomes positive. So this is a 10 at the end, and those simplify. That means we have a remainder in this problem. And again, we do not use the letter r. We're going to use the proper notation that there's 10 left over when we try to divide by x minus 3. And since there's a remainder in problem 6, 2x minus 3 is not a perfect factor of the polynomial. Okay, moving on to number 7. Number 7 gets a little bit more difficult because the big twist in this one is that your x squared minus 2 is really x squared plus 0x minus 2. And the reason why we have to write that is because we need a placeholder for the same reason that we would need a 0 in front of 504 instead of just writing 5 in the 4. So this is going to be our first trinomial. And for the sake of doing the problem, I like to put a spacer right there. And I'm going to write my polynomial here that we're trying to see if it's a perfect factor of. Okay, so let's take a look at that. This is a trinomial, so we'll have to start writing right there. It's really 3 spaces for these 3 spaces. So what number multiplied by x squared gives me 3x to the 4th? Well, in this case, it'd be 3x squared. Notice how the x squareds are lined up here? That's kind of a nice little trick right there. 3x squared times x squared is going to be 3x to the 4th. 3x squared plus 0x is just 0. 3x, or times that 0x is 0. 3x squared times negative 2 is negative 6x squared. Now I'm going to highlight the fact that this is a different color here. We're going to subtract, which will not change that really, and subtract there. Now this is going to give us a simplified answer, and the rest is going to follow down and drop down pretty easily. So this minus 2x cubed minus 0 or plus 0 is just 2x cubed. And then we have these two being brought together, the negative 11 and the 6 is negative 5 x squared. Moving on, we're going to look and see, after we drop this down, this minus 2x, what do I need to multiply my 2x squared to make it look like 2x cubed, or my x squared to look like 2x cubed? And what we'll multiply by is just 2 and an x. So 2 times x squared is 2x cubed. So x and x squared makes the x cubed. 2x and 0, well, it just makes 0. And 2x minus 2, that's going to be negative 4x, like that. And then we switch to a new color. So this is going to be minus and plus, because when we do our subtraction step, everything changes. That simplifies. Now we're going to bring all this down. So this is going to be negative 5x squared plus 2x plus 5. Now what do I have to multiply my x squared to make negative 5x squared? Well, I'm going to multiply by negative 5. And that gives me a negative 5x squared. That's my perfect match. Negative 5 and 0 is just 0. And negative 5 and 2 is positive 10. Draw a line. We're going to do some switching here. So these cancel out because that's turned positive. That just, again, is going to be 0 no matter what. And then this right here is turning negative. So let's see what we have as our remainder. And unfortunately, we do have a remainder. So this is 2x, and this here is negative 5. 2x minus 5 is our remainder. We would write this remainder not as an r 2x plus or 2x minus 5. We'd write it as 2x plus 5 over our trinomial, or this case our simplified trinomial, which is this binomial that we just got. This is a remainder when trying to divide by this. So it's about time that I show you an example that has no remainder. So this last problem here that we're going to do together has no remainder, and that will be kind of nice for us here. Now, one thing about this problem is that you should put it in order. It's not going to work if you don't have your polynomial in order, so please make sure you do that. So then we have minus 10x squared plus 4x minus 8. Now, again, we are dividing by this x squared minus 4, so we'll need a place value there. And I'll just put 0 there in this time instead of 0x. I know some mathematicians might be looking at this going, you're making 0 negative and you're putting an x there. It's completely not necessary, but I just wanted to do that so you would see that there's no x's there. So that's why I put the x in there. Starting here, to multiply to get my 3x squared is 3x squared, and x squared is going to give me 3x to the 4th. Just like our last problem here, this is going to start out the same and then get a little different here at this step here because this is going to be negative 12x squared. Now let's go change colors here to show my subtraction step. Minus, that doesn't change, plus, these simplify, and this makes a positive 2x. Change colors here. So positive 2x squared. This drops down. And that drops down here. Alright, so what do I have to multiply to get a negative x cubed here? Well, probably just a minus x would be fine. So multiply by that gives me a negative x cubed. That gives me 0. And this gives me positive 4x. And it's positive 4x because negative times negative is positive. Alright, let me change colors here. And we'll see that in this case we're going to have some more canceling, which is going to be kind of nice. Okay, so these simplify. When I turn this to positive, when I turn this to negative, these simplify. But it's not like we have gotten rid of everything yet, because if you take a look at this drops down as 2x squared plus 0, and this drops down minus 8. Now what's great about this is to get my 2x squared, from my x squared, I just have to multiply by 2, and that gives me 2x squared. times 0 is 0, and 2 times negative 4 is negative 8. Well, I'm not even going to change pen colors here, because if I subtract, this doesn't change, and subtract to make that opposite, you'll notice that all these simplify. You have no remainder, so this is your answer, unlike the answer plus the remainder we've been receiving in a lot of these problems. And this tells me that x squared minus 4 is a factor of this polynomial of degree 4. And the reason why we do this long division is because we don't know a lot of factoring tricks with polynomials that have a degree greater than 3 for the most part. So this 5-term polynomial, unfactorable by old means, is factorable using the long division method. All right, thanks for watching.